discuss the second part of the lecture 5. We are going to start from the integrity constraint, normally called the IC. So, database management system must prevent entry of the incorrect information. So, you know that when you get the relation, always you have to enter the correct information. As also, another characteristic is the same data cannot be repeated several times in the database, so that you have to reduce all the things. We will discuss that in the next lessons, called the normalization. So to prevent this, the constraint or the conditions are specified on a relational schema that is called the integrity constraint. The database which satisfy all constraints specified on the database schema is a legal instance. For an example, if you declare a certain what we call the attribute in a certain domain, having the domain, you can enter only that value. For an example, age. And you are going to declare as the integer, then you can only enter the integers as the age in the person or the student database. So when you enter the integer, this will be the current legal instance. So database management system enforces constraint, that is permits only legal instance to be stored. And name string, when you enter the numeric value to the name, you will be given error message that is not allowed to enter the numerics. And also, when the application is run in the database management system, checks whether the violation and disallow the changes to be to the data that violates the specified IC. So when you specify the integrity constraint, and when you are going to while you are going to design in the database, and when you are going to enter the data to the database, it will check the integrity constraint, that if you are going to violate that, you will be given an error message. So there are 4 integrity constraints. One is specified and enforced by the different types. One is, this is specified. The database administrator or the end user define the database schema. Whoever define the database schema must put the correct integrity constraint, and enforced when the database application is run. And also DBMS checks for violations. Once defines this integrity constraint, and when you are going to implement or enter to the data, it will check, and if you are going to violate those values, you will be given an error message. So disallow violating entries. So there are 4 integrity constraints, as I explained before: domain constraint, key constraint, entity integrity constraint, and referential integrity constraint. So you have to keep this in your mind: domain constraint, key constraint, entity integrity constraint, and the referential integrity constraint. We'll discuss one by one. So domain constraint. What is this domain constraint? The value of the column represents the attributes of our logical design, and also when you convert to the schema, then you can write as the column. The column attribute represent the column must be drawn from the domain associated with the column. So restrict the type and also value that can appear in the field. For an example, name, address can be defined as a char. Char means the character, and within brackets you can give the maximum characters that can enter. So the if you enter like char 25 when you're going to design a database, the 25 the space to enter the 25 characters will be allocated first. But if you declare as varchar variable char 25, the space is not allocated. That will provide the facility to the maximum of 25 characters. For an example, sometimes you are going to enter the name less than 25. In such case, variable char is very, very important, because you can reduce the space or the allocated space from the memory to enter the data. So then this is the domain constraint. When you after this declaring like this, if you want to enter the different value to this one, for an example a numeric value, you are not allowed to enter after designing a GPA, grade point average, that is real. That number is greater than 0, greater than or equals 0, or less than or equals 4. Within 0 to 4 you can enter this GPA. These are called the domain constraint. Understand the domain constraint. The value in the column must be drawn from the domain associated with the column. The key constraint. Key constraint actually is the statement that the certain minimal subset of the field of a relation is a unique identifier for a tuple. You know that there are two types of key. Now you can understand what is the super key, primary key, foreign key, and candidate key. Candidate key is, that means candidate keys. So you know the definition of the primary key. Primary key is the minimal set of attributes that can derive a certain tuple, the minimal set of attributes, and also unique one. So the primary key is, and also the unique identifier for a tuple is the primary key. And sometimes the minimal subset may not be a tuple and one attribute. Sometimes you will have to get two attributes together to get as the primary key. That which means two tuples in a legal instance cannot have the identical value in all fields of the key. So why can't we use the name as the primary key? Because we may have sometimes the same name, the persons having the same name. So normally if you are working in a company, you will be given a certain employee ID. Employee ID is a unique one, and also it has a meaning of that. And also they can use as your NIC number as the unique key, but they are not going to use the NIC number. NIC number also the primary key, but they use the employee ID because employee ID has a certain meaning. Sometimes they are going to introduce the department as well as the entering date with the serial number or something like that. So entity integrity and referential integrity constraint. Entity integrity constraint, that is, states that primary key values cannot be null. Entity integrity constraint. The primary key values cannot be null. That means if there is a null value, what? Can you access that tuple? No. Definitely the primary key must have a value. And also this is because the primary key value are used to identify the individual tuple. That is the reason. Unless it has a value, how can you access that tuple? So the primary key must have a value and cannot be null. A referential integrity constraint means sometimes information stored in one relation is linked to the information stored in another relation. You know that the course and the student. So sometimes information stored in one relation is linked, that is using the relationships. Sometimes many to one. One course is taking many student. Okay. If one is modified, the another must be modified to keep the data constraint. In such case, when you are going to modify one and another must also be modified to keep the data consistent. Otherwise, there may have some inconsistency of the data. That is called the referential integrity, and integrity constraint involving both relations must be specified. You know that foreign key can be used to reference to the primary key of a certain table. Using the foreign and primary key, you can get the relationship and you can get connect the tables. IC involving two relations is called the foreign key constraint, as I explained. Foreign key enforces referential integrity constraint. So the foreign key enforces the referential integrity constraint. When I summarize the content of this slide, the primary key cannot be null. From the primary key, you can access the tuple. Also, when you get the foreign key, enforce the referential integrity constraint, and two tables can be connected using the foreign and primary key referencing and referenced relations. Here you can see the value of the foreign key column. The value of the foreign key column here can be either value of an existing primary key in the referenced relation or the null. Here you can see primary key of the student SID is the same as the student ID of the enrolled one. The foreign key, you can get the same value here. DB operations, and when you consider database operations and constraint, integrity constraints are specified when a relation is created and enforced, or the checked when the relation is modified. There are three type of modification you can find even in the not only the database. Most of the database application must have these modification. One is the insert. You can insert the value to the tables and delete the tuples in a relation, as well as update, change the values of some attribute in the existing tuples. And also, when you use the database management systems, another one you can see the retrieve the data. That means if you want to visualize or the display the data or the filter the data, so those things are can be done as the database operations. So insert operation, actually the insert operation can violate the following constraint. When you are going to insert, it will violate these following constraints. One is domain constraint. You can enter the invalid value for the attributes or the columns. And key constraint, duplicate key values. Sometimes you will enter the same primary key to another tuple, so you will be given an error message. Entity integrity constraint means you will enter the null value for the primary key. And referential integrity constraint means non-existing primary key value. So you are going to enter the non-existing primary key as the foreign key of another table. understand correctly, non-existing primary key as a foreign key of another relation. So you know that the primary foreign connection relationship. So these are the violation of insertion operation. Invalid domain value, duplicate the key. Sometimes you will enter the null value or non-existing primary key values. We can explain like this. Here, domain constraint invalid. That you are going to insert ABC. That you have to enter to the order like this. This is integer char, integer and real. Here you are going to enter the ABC. Is the ABC integer? No. This is SID value is not the domain. You have to enter the value having 5 figures. Key constraint 5366. You are going to enter the 5366 which is available here in the SID as a new to the new tuple. This is all called the duplicate the key value, key constraint. Another one is entity integrity constraint, means you are going to enter the null value for this primary key. That also wrong. And also last one is referential integrity constraint, means you are going to enter the ITA 53900. 53900 is not in the student SID. No such student. So that also referential integrity, because non-existing primary key value is going to enter to the SID. Those are the example of this. Delete operation. Delete operation can violate referential integrity. So here you can see enroll key has these two here, 53666, 53666. Delete operation can violate referential integrity. So this is wrong actually, when because you can't have this identical 53666 is there and CID, student ID, course ID, these two courses grade B and C for this student. Delete operation can violate referential integrity. And when you go to this link, here SQL server, I will give it to you to get then to knowledge of this one. SQL server foreign key with the cascade delete. And when you are going to delete, the SQL Server tutorial explain how to use the foreign key with cascade delete in SQL Server with syntax and the examples. What is a foreign key with the cascade delete in SQL Server? So this is for your extra reference. I add this one. Foreign key with cascade delete means that if a record in that parent table is deleted, if you are going to delete a record from the parent table, record in the parent table is deleted, then corresponding records in the child tables will automatically be deleted. So from this cascade delete, all the records related to this parent table must be deleted. This is called the cascade delete in the SQL Server. Cascade delete. The foreign key with the cascade delete can be created using the create table statement or the alter table statement. I will explain later this one, because this is actually a little bit advanced to explain now. we have to understand the create table. In that time I will explain. Now here you can see what you are going to delete. You will confuse whether you want to delete which one you want to delete. Here this will refer so two options. When such situation is there, you can have two options. One is reject the deletion. Next one is cascade delete. Rejection the deletion and cascade delete. Cascade delete means all the data related to this one in the child table must be deleted. And cascade operation I will explain later in this DBMS lecture series. Next one is update operation. Update operation can be considered as deleting a tuple and reinserting a tuple with the new values. Deleting a tuple and reinserting the tuple with new values. All constraints discussed in insert and delete need to be considered domain constraint, key constraint, entity integrity constraints, and the referential integrity constraint. So you have to refer these four while you are going to update the table. Domain, you have to enter the right domain values. You have to be careful whether duplicate key values, not to enter the duplicate key values, and primary key cannot be null, as well as non-existing primary key value also. So the class exercise here, consider the following relations for the database that keeps track of a student enrollment in course and the book adopted for each course. Student, course, quarter information, enroll, book adapted, as well as text books. So each relation has several attributes. You can see this student has SSN is the primary key, name, age and birth date, course and course ID is there, also C name and department, quarter information, that is quarter and the description, enroll, SSN, course ID, quarter and grade. You can see these three. SSN is the student, course ID and the quarter, and you can get the grade. And next, book enroll, book adoption is the course number, quarter and book ISBN number. Text books, book ISBN number, and you can see this is the foreign and primary connection you can find. Book title and publish and the author. Draw the relational schema diagram specifying the foreign keys for this schema. How you are going to draw. So how you are going to draw? You can see from the enroll, all these are primary foreign keys, and you can draw the SSN and also course ID as well as quarter foreign primary relationship. And also course number and quarter. Course number, book adaptation has this primary key is the book ISBN, and these two are foreign keys. Text, the book Text actually book, you can get the ISBN as the primary key, book title and the publisher and the author. So we will discuss this one in the next class, drawing the relationships. So ER and relational mapping. ER and relational mapping. So in the database design process, we firstly derive the conceptual model. That is, you can see that entities and the attributes, that is called the conceptual model. Then this model needs to be mapped with the relational model in order to be implemented using the relational database management systems. So the conceptual schema can be converted to the relational model, moving from the conceptual to the lower level logical model called the relation. The ER is independent from the details of implementation of relational network or the object-oriented model. So entity relationship model is independent. There is no any relationship with this network or the object-oriented model. This section discusses the rules that we use to this process. We are going to discuss what are the rules that can be used in this process. The mapping actually, ER and relational model. ER model, we can have the entity with the attributes, and also relational model we call the relation. The relation name represent the entity name, the columns represent the attributes. For an example, here you can see, we can like artist is the name of the relation and these are the attributes and represent the columns. ID here, the primary key, and name. So ER model, once again, composite attributes. If there are composite attributes, entry full name, first name and the surname, employee and surname and the first name, likewise set simple atomic, surname, first name. Here you can see multi-valued attributes. Phone is the multi-valued attributes and name is the composite attribute. In such case, how we can implement the multi-valued attributes? Employee, ID, name, and also once again this is, you can see, and once again multi-valued attributes, employee contact, phone ID. ID is this one and phone number. If there are different phone numbers, home, office and mobile, you can see as the home, office and mobile with the ID. So from this ID you can get the employees detail, the foreign and primary, referencing and referenced. Employee manage department, that is this is partial and this is total participation. If there is one-to-one relationship R for the entity A to B, and if B is not a total participation, B is not the total participation with A or on R, then foreign key is placed in B. So this is one important concept. If there is a one-to-one relationship in R from entity A and B, one-to-one relationship A and B, if B is not total participation, B is not total participation, employees are not total participation, with A, with department on R, then the foreign key is placed in the B. The foreign key is placed in the attribute or in the relation that is not the total. B is in the total participation. That means you have to put the foreign key in the department. If B is in total participation, here department is the total participation with A, that is employee, on this relation R, then the foreign key is placed in the B. The foreign key that is EID is placed in the department side. So you can see here EID manager number is placed in here, the total participation side. You please keep in this your mind. This is very, very important concept. Where you want to put the foreign key in a relation. The foreign key always put in the total participation relationship. One-to-one with total participation. In such case, if there is one-to-one relationship R from entity A to B, and if A and B both are total participation, A and B both are total participation with R, this relation, then A and B can be collapsed as one table. A and B can be collapsed as one table means we can get these two tables together if these tables are total participation. Okay, next one. Next one. 1 to n conversion. And 1 to n relationship, post the identifier primary key from the one side as an attribute to the many side. 1 to n relationship, post the identifier, that is primary key, from the one side as an attribute to the many side. That means here you can course is registered student. Many students can register one course, one to many, and you have to put the primary key from one side and attribute to the many side, so that you have to put attribute in the course number to the student side. Likewise here CID, course ID, you have to put that is the many side, CID, student side. Foreign key and primary key. M to N relationships. For M to N relationships, create a new table and put the identifiers from each one of the linked entities as attributes in this table. Class and student, many to many relationship. So class create a different relation having these two keys and any other attributes. CID, class ID, SID, course ID, student ID and class ID with marks. You can see like this. Foreign key, and this also the foreign key here. Mapping n array relationship. N array relationship, more than you can see. N array relationship, the relationship relation and n foreign keys, so that you can, by getting these primary keys, you can create a one relation like this: PK, PB, PKC, PKD, PKA, B, C and D. So mapping weak entities, you know that employee and the dependent, the insurance policy dependents, the weak entity. This is called the weak entity. The relation can combination of partial and primary key. Partial and the primary key. You can use the primary key with the name. The employee dependent, employee ID with the name of the dependent. So if you can find some similar names to the other employees, that doesn't matter, because employee ID is the unique one. Then finally your turn. Map a relational schema. So map a relational schema, relationship typically labeled as verbs or the names of aggregation. Here you can see end to end, M to N relationship. This is actually for the homework, and then from this chapter I explain the ER to the relational mapping algorithms. Step 1, mapping of the regular entry types, multi-valued attributes, composite attributes. Step 2, mapping of weak entity types. Step 3, mapping the binary 1-to-1 relationship, mapping binary 1-to-n relationships, mapping binary m to n relationships. Finally, you have to map n-array relationships. So, correspondence between the ER and relationship model, these are the things: entity, that is relation, 1-to-1 or 1-to-n relationship type, foreign key or relationships, and m to n relationship type, relationships, relation, and 2 foreign keys. N-array relationship with n foreign keys, and simple attribute, you can use that one attribute. Composite attribute, set of simple component attributes, multi-valued attribute, relation, and foreign key. Value set, that the domain key attribute is the primary or secondary key. So that is for the end of the lecture.